In a previous video on compound inequalities, we talked about the fact that if it's an and problem that you're presented with, that typically the resultant graph is going to look like a dumbbell, something like this. And when you have an or problem, the resultant solution graph is going to look like both ors. So, I'm not sure if you can appreciate, here we go. So here for this OR problem, you have two lines heading out in different directions, very similar to both ORs, O-A-R-S. Again, a line going this way and a line going that way. Let's first start out with a few compound inequalities that are going to conform to that framework. So here we have an OR problem. We're expecting two both ORs. So let's go ahead and solve this. We're going to take the -2 and bring it to the other side, and we're going to end up with m is less than -6. Or, if we multiply here on both sides, we're going to get m is greater than 8. So we go down to the number line below, and we're going to have m less than -6, or m is greater than 8, which is a little bit off this graph. Okay, so far so good. Let's now move on to an and problem that again will conform to the construct. So here we go. We have -1 is less than 9 plus n, which is less than 17. So recall, folks, when you have a structure like this is an and problem. So if we want to rewrite it, it would be like so. -1 is less than 9 plus n, and 9 plus n is less than 17. So let's go ahead and solve this. We're going to move that 9 to the other side, and we're going to have -10 is less than n, but I like to write the letter first. So it's going to be n is greater than -10, and let's go ahead and solve this. We're going to take this to the other side, and we're going to have n is less than 8. Okay, so this is the overlap method that I want you folks to use when you solve these problems. So we have n is greater than -10. So I'm off the grid again. This would be -10 over here. And it's greater than, so it's going to be just an open circle. So that if n is greater than -10, that includes this entire line, like so. Now we have n is less than 8. So 8 is going to be here. We're going to have an open circle, and we're going to have a line that goes this way. So folks, if this is an and problem, again, this is -10 down here, sorry. If this is an and problem, the solution to this is going to be where these two lines overlap. So that's going to be in this section right here. This is the only section where you have both a black and a red line. So if we want to clean this up a little bit, the final solution is going to look like this. We're going to start at -10 with an open circle, and we're going to go all the way to +8 with an open circle. We're going to have 0 somewhere in the middle, and this will be our solution set. So this is a dumbbell with an and problem, which is usually what we get. But the thing I want to focus on here, folks, is this overlap method when you're doing and problems. I think it is very helpful. So folks, the first two examples that we've done conform to the normal, or should I say expected result. We have an OR problem where the final result looks like both ORs. We have an AND problem where the final result looks like a dumbbell. Now I want to point out something. During the process of solving both of these, there was no flip of the sign. Okay, no flip of the sign. And in addition, when you put the variable first, you have the variable less than something and the variable greater than something. Here we have the variable greater than something and the variable less than something. Now, most of the time when you see a problem that does not conform to this, and we're going to do a few examples in a moment, you're going to have either a flip of the sign as you're solving, or it's going to violate this pattern. So for example, you might have something like this. X is greater than 3 and X is greater than 7. Or you might have X is less than 2, X is less than 10. In other words, these are going to be the same. So it doesn't always happen, but if you see a flip of the sign or you end up with this scenario, be very wary that it is not going to conform to the boat oar and dumbbell pattern. Next, we are given an AND problem. So unless we see one of the two warning signs that we just reviewed, we're going to expect a dumbbell pattern. Okay, this first one on the left, we're going to move the 7p over, subtract it, we're going to get p less than or equal to. We're going to move the negative 13 over, change it to 13, and we're going to get p is less than or equal to 11. Here we're going to move the 2p over. We're going to end up with 2p is less than. We'll bring the 20 and subtract it. We're going to have negative 6. We're going to divide both sides by 2. We're going to have p is less than negative 3. Okay, folks, here is a warning sign. We have p is less than something and p is less than something. That is a warning sign. That, along with flipping the sign, which we didn't do here, tells us that we may not get a dumbbell pattern. Okay, and problems, we're going to look for overlap. So let's start here. P is less than or equal to 11. Okay, as usual, I'm off the chart here. I don't know why I'm bothering bringing this thing down, but here we go. Here's 11. We're going to have a closed circle, and we're going to have a line going this way. P is less than or equal to 11. Then we're going to come in with a different color. Negative 3 is also going to be a closed circle, and we're going to have a line going that way. So folks, when we clean this up, our final solution set is going to look like this. Here's your 0 for reference. Here's your negative 3 with a closed circle with an arrow going this way. So this is not a dumbbell situation by any means. Recall, when you have an AND problem, your final solution is going to be where the two lines overlap. This is the only section where we have both a red and a blue line. Next, we have an OR problem. So unless we see a warning sign, we're expecting both ORs. Here we go. Immediately, we see on the one on the left that if we subtract 14r from both sides, we're going to end up with the variable getting lost. So we're going to end up having 20 is less than 16. So that is a false statement. Therefore, this part of the problem has no solutions. Okay, we recognize this as a bizarre situation because normally the pattern that's going to produce an OR answer, both ORs, no flip of the sign, and have the variable less than something, the variable greater than something. Not always, but the fact that we don't have this is a tip-off that we will perhaps not have a typical both OR solution. Okay, so here we go. Let's bring this positive 10 over, and that's going to give us an R over here, and bring that over here. We're going to have negative 7. I like to rewrite this with the variable first. So we're going to have R is less than or equal to negative 7. Okay, folks, when you flip things like this, not flip the sign, but flip the order of the variable and the constant, double check. Here, before we had the point with the capital R, and after the point is still with the capital R. That means you did things correctly. So for our final solution, we're going to have R is less than or equal to -7, which would be down here. And this contributes nothing to the final solution. Now, the total is not no solutions. If this was an and, then it would be no solutions. Once you have no solution in part of an and problem, that means the final solution is going to be no solutions. But this is an or problem. So while the no solution section does not contribute to the final answer, this one does. So that is your final solution. Folks, before we move on from this problem, let's pick a point in our proposed solution area and let's see if it is correct. So let's pick -10, that's within our shaded area. If we plug in -10 over here, it is not even going to be plug-inable because immediately we're going to lose the variable. However, if we plug in -10 over here, we're going to have 8 plus 100 greater than or equal to 15 plus 90. 8 plus 100 is 108, and 90 plus 15 is 105. So all we need is for one of these to be true, and that indeed is the case. We don't need both to be true because it's an or problem. So this is the correct solution set. Next, we are given another and problem, so let's proceed. On the left, we're going to throw that over the fence, subtract it, we'll have 7a. We'll throw the 15 this way, we'll have -15, which will result in -7. We're going to divide both sides by 7. We are not going to flip that sign. Just because there's a negative here and we're performing division does not mean we flip the sign. We only flip the sign if we, in fact, with our pen, write a negative sign. And we did not do that in this case because we're dividing by +7 to isolate the a. Okay, so we're going to have -1 is greater than a, and I like to write the constant first. A is less than -1. We double check that before the switch, the point is going to the a. After the switch, the same is true. Let's move to the upper right side. We're going to take this -14, throw that over the fence. 14 minus 3 is going to give us 11a. Now we're going to bring this 13 over. 13 minus 13 is 0. We're going to divide both sides by 11, and we're going to have a is greater than or equal to 0. Again, I'm going to have the a first, greater than or equal to 0. Double check that I have the point going to 0, the point going to 0. Okay, folks, let's go ahead and plot this. We have a is less than -1. That's going to be going this way to the left, and a is greater than 0. Okay, this is an and problem, so we look for overlap. There is no overlap. Therefore, this is no solution. So this is one of the rare occasions with an and problem that we do not get a dumbbell. And not only that, we didn't have any warning signs. For example, there was no flip of the sign. Here we have a less than something, a greater than something. So that's why some of the tendencies that I've mentioned, you have to remember, they're not 100%. They are trends, they give us some intuition, but at the end of the day, when you have an and problem, you have to have some overlap. And there is none here, therefore there are no solutions to this problem. Next, we have an or problem. On the left, we're going to bring this x to that side, subtract. That's going to yield 7x. We're going to bring the 4 to the other side. 18 minus 4 is 14. We're going to divide both sides by 7. And we're going to have 2 on that side. X over here. We're going to flip this around. And we're going to be careful. The point is pointing towards the x. And we want that when we switch the order. Okay, so we have x is less than or equal to 2. Now moving over here, we immediately see that there's 15x on both sides. So if we subtract those, we have negative 15 is less than positive 5. This is a bizarre statement. The variable has been eliminated, but it's a true statement. So if you have a situation where the variable is eliminated, and we see this when we solve system of equations using elimination, and if the variables completely eliminate, we ask ourselves, is this a true statement? Is positive 5 greater than negative 15? It is. Therefore, any x value you put in here, this is going to be true. So this portion of this OR problem is all real numbers. Infinite number of solutions. So if we were going to go ahead and graph that down below, that would encompass the entire number line. Let's do a different color. That would encompass the entire number line, all real solutions. So yeah, I mean, if you want, we can add x is less than or equal to 2, add that, but that's just piling on. All we need is this initial all real numbers in an OR problem to recognize that this entire compound inequality, the solution set is going to be all real numbers.